Hello everyone. In this video, we're going to focus on a measurement based on assessing sustainability. We are going to talk about the following topics. First of all, conceptualization. Secondly, operationalization. Thirdly, strengths and limitations of this operationalization.
I'm going to answer the question that how sustainability is conceptualized. Sustainability is not a single idea. Instead, it is a multi-dimensional system which is tied to a definition called SDG. It includes three pillars: economic development, social inclusion, environmental sustainability. In addition, it is a simultaneous progress and none is replaceable. For instance, economic growth is not sustainable if it harms environment. But how can we conceptualize it in a concrete, abstract measure? This assessment isn't just looking at one specific time. It is two stages. Retrospective, we look back at 2015 data measuring how 139 countries performed on sustainability then, and find their strengths, call out their weaknesses, and see where the global gaps are. And then the prospective. Then we predict 2030 trends. We spot which challenges still won't be solved and check if policies are actually working. Non-linear interdependence between pillars. Conflict or they reinforce each other. For example, unregulated economic growth may both harm environment and society.
After we have a brief concept of the methodology, a new question is raised up. How can we put that into real life? Well, the research mainly introduces the operationalization, which translates the conceptual framework into concrete, actionable steps, from indicator selection to index calculation. That includes a process following 5 sequential stages. Stage 1: Indicator screening and eligibility. To operationalize the 17 SDGs, the study selects 25 measurable indicators based on two strict criteria: data availability and macroeconomic compatibility. The first aspect is data availability. Indicators must have sufficient global coverage. They must, for example, include 139 countries. For example, gender equality is excluded because data on gender-based violence was only available for 100 countries, risking biased pillar-level results. The second regression is macroeconomic compatibility. Indicators must link to pre-existing macroeconomic variables such as GDP or employment rate to enable future projections via the model. These without empirical ties to economic drivers such as subjective well-being are excluded. Stage 2: Data collections. Data must source from authoritative international databases so that they can ensure reliability and consistency. For each field, we listed the reliable sources. The first one is social indicators. For example, World Bank, UNESCO, which according to literacy, and WHO, which according to health life expectancy, and the Transparency International, which according to corruption rate. The second aspect is environmental indicators, which listed energy intensity and GHG, which means greenhouse gases, shorting emissions from agriculture and endangered species. The last one is economic indicators. For example, GDP growth, public debt, employment rate. These are all reliable resources. And missing data, for example, for small developing countries, is replaced with regional averages. For example, Arab averages substitute the one in Qatar, which is the small developing country in Arab, so that they can maintain sample size. The sources, according to the PPT, are some reliable sources listed. Next, we move on to stage 3, normalization to a common scale. In brief, to enable cross-indicator and cross-country comparisons, raw data is normalized to a 0 to 1 scale, which 1 means fully sustainable and 0 means fully unsustainable in this scale. The method differs by opposite indicator type, which are divided into positive indicators and negative indicators. Positive indicators, in these indicators, higher values means better sustainability. For example, renewable energy share is a positive indicator, and negative indicators on the opposite is higher values means worse sustainability. For example, poverty rate. Look at the picture. These are formulas shown. You may check it on the internet if you are interested in mathematical formulas. The fourth stage, aggregation into pillars, which in this field, pillars means different aspects, and multi-dimensional indices. Aggregation combines normalized indicators into meaningful scores, capturing both individual pillar performance and overall sustainability in this stage. The first aspect is about pillar level aggregation, which arithmetic mean of normalized indicators within each pillar, as we all know, economy, society, and environment, to calculate pillar-specific scores. For example, the social pillar score is the average of normalized poverty, literacy, and physician density indicators. Look at the formula shown. The second aspect is about overall sustainability index, which we use as we all know, Chocolate integral, a non-linear aggregation tool to account for pillar interactions. This may not all know. It is a specific tool in quantitative research, and aspects elicit fuzzy measures which assign weights to individual pillars. It's like society bigger than environment, bigger than economy. Then we have pillar synergies, which means the pillars act together, how they act together. The strongest weight must placed on the environment society synergy, reflecting that sustainability requires joint progress in these two areas. Look at the formula shown. It's formula 4, and we have the table 3. Mobius representation elicit. The final output is a global ranking of 139 countries based on their overall sustainability score. It's 1 to 0 or 0 to 1. Ultimately, we have our fifth stage, validation and visualization, which is common in this field. We can check the validation of data by geographic mapping according to this picture, figure 10. We have Ford's map of pillar and overall scores to identify regional patterns. For example, sub-Saharan Africa's low social scores. Secondly, we have correlation analysis. We have to compare plots of economic and sustainability scores to review trade-offs. For example, as we all know, high economic growth in China in the history and versus the low environmental scores. Finally, we have case comparisons. We set in-depth analysis of similar countries, for example, Norway versus Russia versus China. They have common spots. We use them to explain ranking differences according to the Figure 12.
Now I'm here to talk about the strengths of this operationalization. First, it offers a rigorous norm, which makes it comparable globally. It takes multiple pillars of a country into account. For example, a country's environmental record, average income, environmental policies, so that it offers a cohesive and accurate reflection of a country's SDG. It is also policy relevant, meaning that the results can directly create practical policies. For example, the framework can identify that India's low social score stems from low literacy, guiding investments in education. It is also a transparent process. Clear documentation of the research process allows other researchers to replicate the research and provide critique on it. However, some weaknesses cannot be ignored. When some SDGs are excluded due to lack of data, it can disrupt the results dramatically. For example, omitting gender equality ignores a key social dimension of sustainability, potentially giving exaggerated scores for countries with high gender disparities. You might also rely on outdated data, especially for less developed countries. Rigorous thresholds might also ignore country-specific contexts. For example, a 60% renewable energy threshold may be unrealistic for energy-poor nations, treating them unfairly. Moreover, information from related pillars could be exposed to bias, because researchers receive information from related expert panels which are mostly Western. This may reflect Western-centric views of sustainability, overlooking information from local communities and governments.